Okay, moving on to ground reference maneuvers. Now we're going to talk about the rectangular course, S turns across the road and turns around a point. We're going to bypass 8s on pylons, that's a commercial level maneuver, and we'll talk about those later on. So let's talk about the rectangular course. This is a maneuver in which the ground track of the airplane is equidistant from all sides of a selected rectangular area on the ground. Why do we care? Because it simulates conditions encountered in a traffic pattern in preparation of pattern work. Now, this is going to be a slightly easier pattern than trying to go to the airfield and do those because you're not dealing with constant changes of altitude. We're just going to be at one selected altitude the entire time, right? We're going to talk about selecting an altitude and reference point, the basics, and performing the rectangular course. This is what it looks like. We're going to enter on the downwind just like we would at a traffic pattern at an airport. We'll turn base, upwind, and crosswind. We'll talk about each leg here in a little bit. Now, our entry altitude. It is a ground reference maneuver, so you want to be close enough to see ground reference points. I believe the ACS allows you between 800 and 1,200 feet above the ground. I like shooting for 1,000 feet above the ground because that is exactly the altitude we're going to be at for the traffic pattern altitude. We also want to select a good reference point, a nice, rectangular field, a set of roads that make a nice rectangle, something along those lines. Now, this replicates a traffic pattern, so let's look at a standard traffic pattern at an airfield. We're going to take off into the wind, so if the wind's blowing into our face, we're going to take off. This is the upwind leg. We're going to climb up to 700 feet above the surface, make a left turn to crosswind, and then keep climbing up to 1,000 feet above the surface. And now we're going to turn to downwind. And as we turn downwind, we're going to fly parallel to the runway and maintain 1,000 feet above the surface until we are abeam the numbers. Let's say this is, 1, 6. We're going to keep flying until we're abeam the numbers, basically level with our landing surface. And we're going to start messing with our power settings and execute, a 500 foot per minute rate of descent and descend down to, again, 700 feet above the ground, turn base, and then turn final. And of course, at final, we want to be making sure we are configured to land, landing gear down, flap set, trimmed off or whatever. By this point, we should have conducted our pre-landing checks. I like to do them here on the downwind, and then again on final, just in case I missed something. Don't want to be landing with our gear up. So that's the basic traffic pattern. Now, if we go to the rectangular course, it's just going to be the exact same thing. If the wind is coming from this direction, this will be our downwind leg, this will be our base leg, upwind, and crosswind. But the difference here is we're going to be at 1,000 feet, or whatever altitude you've selected, the entire time. So we don't have to worry about messing with our power settings or changing our altitudes. Now, just like before we enter our maneuver, we're going to do our clearing turns. That's right. So I'm going to tell the DPE, sir, I'm going to clear my left wing first and make a left turn, clear the airspace, make a right turn, clear the airspace. And don't forget, you can actually do a full circle if you want to do a clearing turn that way instead. So we've completed our clearing turn. Excuse me. We've completed our clearing turn. We've selected our initial heading, outside reference, bugged our initial heading, selected our course, this set of roads, whatever it is. And we want to enter on the 45, just like we do in a traffic pattern. On the 45, we get onto the downwind leg, and then here, when we clear that outer boundary, we're going to make a turn to base. And now, because of the wind, if we don't make any wind correction angle, we're going to get blown off course. So we actually have to crab into the wind. Now, that doesn't mean that we need to be flying at an angle like this the entire time. We're actually going to be wings level, but instead of being, having our nose pointed at, let's say, this mountain, we'll have our nose pointed off to the left of it to account for this wind blowing us off course. So we'll have our nose pointed not parallel with our boundary, but somewhere off to the left to account for this wind, and then crab all the way to the next corner, where we're going to turn less than 90 degrees upwind. Now, up here on the downwind, the wind is pushing us further along in the same direction that we're flying, so our ground speed is going to be greater. Here in the upwind leg, we're going to be fighting the wind, so our ground speed is going to be slower. We're actually going to be moving slower over the ground. Even if our air speeds are the same, our aircraft will be moving slower over the ground than up here in the downwind. Now, as we clear our boundary, we're going to make another turn across the wind, literally crosswind, and we'll have to crab into the wind again. Now remember, Once we are in this leg, our wings are level, but we're pointed, angled away from our reference line here to account for this wind. Because if we didn't, the wind would blow us off course and we'd have this gross-looking non-rectangular maneuver. All right, so we're going to crab into the wind and then turn more than 90 degrees again to go downwind, and then we can exit or continue on. It's definitely worth practicing. Now, the purpose of this, remember, is to learn how to maintain our track as we fight a wind that is not really helpful to us. And if you imagine a little boat trying to get across a river, the water's blowing this way. If you're a little boat trying to get from point A to point B, and you try to just put your nose there, the water current's going to blow you down the river. But if you put your little sailboat kind of at an angle, that water is going to help you basically go straight across the river. And that's the idea behind this wind correction angle, learning how to deal with that wind blowing you off course. And I think I covered this already. Basically, we're maintaining track using wind correction angles to get where we want to go. Questions? Of course, if you have a question, just go ahead and drop them in the comments or DM me on Discord. I've decided to break these apart so that's not one hour-long video. I hope you guys like it. You guys let me know what you prefer. Cool. Thanks for watching. See ya.